So we defined a class rectangle, that's what we have defined. Okay. So in a class definition, yes, what are the various members which go in a class definition? So far, whatever we have seen, a class can have instance variable. Fine. Fine. Example is length and width, which we have used in our rectangle class. Okay. So yes, we can have instance variables, right? Okay. So class has instance variables. What else? It can have methods. Fine. Instance variable example was length. I'm not repeating the whole definition, but you can just say, okay, instance variable examples are length and width, right? Okay, fine. Next thing we can have is methods. Yeah, what is typical about instance variables? They have a separate copy for each object. When unless object is there, they don't exist. Okay. As you create objects, each object has its copy of the instance variables. Okay. Fine. Methods they define interaction with the objects. Fine. If we have an object, we may be able to use method on the object to interact with the object. Right? It is your interaction with the object. Okay. So methods, yes. What are the things required in a method? They take some inputs. Fine. So that's a parameter list, and they will have a return type. Okay. Fine. Method examples. We have defined a lot many methods here already. What are the examples of methods we have? Area was a method. Right? We have method called getLength. GetLength, GetWidth, right? We even had set dimensions kind of thing. Okay, and then we can have overloading of methods. Fine, overloading of method was we can use the same method name, okay, but with a different type of input parameters. Okay, parameter list is slightly different. Okay, fine. So methods can be overloaded. Fine. What else we had seen? Set dimensions. Then set dimensions we had overloaded. Method overloading. And then what are the other kind of members which can go in a class definition? What are the other things we have used? A class can have, see, objects will have to be created. How is the object created? By using new and then give a class name, but there you have to specify a parameter list. To invoke, you will pass the parameters. Right? So what is that thing called? So in class, what do we define for that? We can define constructor. Fine. So a class can have constructor. Fine. Again, like methods, constructor can also be overloaded. Okay, what other things we have seen? And yesterday I think we had seen a couple of things more. What are the other things we can do in a class definition? And see, we are just trying to see what are the various things we put inside a class definition, and what is possible to be put inside a class definition. What are the members of a class? Yeah. So, yeah. After instance variable, what do we have some other kind of variables? Yeah. We can have what kind of variables? Like instance variables, we also have what is known as class variable. Okay. For example, for class variable, we have something called count. Okay, we have something called count, right? So when we say class variable, that means it is not part of the object. It is not dependent on object creation, right? The keyword static is what is used here, and what we use here is the word static. A variable declaration with the word static, that is a class variable. Okay, you have the modifier static to declare it as a class variable. So variables, so when we have static, that means it is not going to be dependent on object. Okay, fine. This variable exists even without objects. Okay, fine. For any class to be used, the class will have to be loaded. So as soon as a class is loaded, fine, static variable comes into existence. Fine. Initially, anything, even before you create any object of a class, right? The class needs to be loaded into memory. So when it is getting loaded, we have the whatever are the static variables, right, in that class, they will get their space. Okay, so they come into existence at that time. Okay, instance variables are not created because no object is there. Okay, fine. So class variables, what else? There's still one more kind of thing which we had seen yesterday. What goes in a class definition? Yeah, what can go in a class definition? And a class can have some kind of method also. It can have static methods. We can also call them as class methods. Okay. When a method is declared as static, okay, so we can have class method or also called static method. Okay? These are the methods which have been declared as static. Fine. What is the difference between static method and a normal method which we have? The class method and the instance method, you can call them as instance methods. So class method and instance method, what is the difference? In an instance method, right, inside the instance method, we can use this, fine, which represents the object on which, because these methods always require an object, they work on an object. That object is available within the method by using the keyword this. As far as the static method goes or the class method goes, you don't have this. Okay, this is not available for class methods. Okay, fine. See, in a method, when we use a variable name which matches an instance variable name, fine, then unless you have some local variable which matches that name, it would be treated as this dot variable name, right? Okay, fine. If there is an instance variable being used, yes, then I'll consider that this is the instance variable on the current object. This you might say, okay, it is nothing but my current object. Current object is nothing but the object on which the method is currently working. Okay, fine. So this is what we have done. Fine. So any questions? Yeah. Want to go through the class definition of rectangle which we have done so far? Yeah. Fine. Okay, let's just check what we have done in the rectangle class so far. Yeah. Okay, so rectangle class, yes, we put the instance variables and two instance variables. We have a class variable. Okay, so fine. We have a static method. Fine, this is your class method. Okay, then we have normal methods, right? We have the methods like area. Okay, get length, get width, set dimensions. Okay, set dimensions was overloaded, and then we had constructors. Okay, so this is one constructor which requires two parameters. Okay, in the constructor, yes, we have used the static variable. We are incrementing the count by 1. Okay, each time a constructor is called, the count will be incremented by 1. Okay. And here in a constructor, what we have done is we have used another constructor by using this and a set of parameters. So you can use this keyword followed by a set of parameters to invoke another constructor. Right? But this kind of a thing is allowed only from a constructor. You can't do it from a method. When this statement, fine, line 41, that statement cannot be used from any place other than a constructor. Okay, you can't do it in a method or other places. Okay, fine. So using this, but whenever we use this, it must be the first statement in the constructor. Okay, it must be the first statement in the constructor, and okay, yeah. So we have fine. So this is what we had right yesterday in our rectangle class. So any questions still so far? Okay, let's see how we can use this class. Once we have defined the class with so many things, okay, let's use each of those items. Okay, as soon as a class is defined, I can use variables. I can declare variables for the class. Okay, fine. As soon as a class is defined, every class has at least one constructor. Okay, we have to understand that even if I'm not defining a constructor in a class, the class will get one constructor, which is the default constructor. Right? You can say it's a no argument constructor. Right? Constructor where no arguments will be given. So anyone can just say new and give the class name without any parameters, should be able to create an object. Okay, so for a class, by default, yes, you can just create a new object. Okay, there are ways to prevent a class from being instantiated. You can have a class for which no objects can be created. And, but for that, yes, you will have to put certain things in a manner such that, yes, no one will be allowed to create the object. Okay. Fine. So we'll come to that part later, but fine. So one is creating object, at this point a constructor is used, right? Whenever you have to create, when we say new, it has to match, right? So you are invoking a constructor from the class definition, okay, by passing the parameters for the constructor. Okay. And then so that's a constructor invocation we have done. So we have used constructor. We have used the second form of the constructor as well. Okay. Okay. Then what we have done is, yes, we have been able to use the acha. Now one thing here. Okay, let's make one change here. Okay. What we'll do is I'll print it twice and show you something which is going to work here. Okay, this you understand is for string conversion. Fine. R1 is nothing but reference to an object, and that object, because it is, so everything in Java can be converted to a string. Fine, that is what we know, because string concatenation is available. You can convert anything into a string. Okay, so I can use, let's try something like this. Oh, do we have a method like toString in the rectangle class? We haven't defined such a method, but let me try and say, the toString is, yeah, convert it into a string. That's what I'm trying to say. Okay, so we have not got a method called toString in the class, right? So this should give a compilation error. Okay, okay, so we compile this. Okay, and let's compile rectangle.java. It's not giving an error. Okay, fine. Let's see what's the output then. Oops, sorry. Let's run the test rectangle. Okay, yeah, we see that R1 is that statement. Yes, we have written it. Once we have written without the toString, other place we are saying, oh, let's run the toString on it. Okay, and they both generate the same output. Right? Just before that R1 length 7, and above that we are seeing after count is 3, we are seeing there are two outputs, right, for the two system out println here. Okay, there are two printlns. Right? In one case, okay, in one case this is without the toString, the other is with toString. So what is toString doing for me? ToString can be used on any reference type. And ToString method is available on any reference type. Okay, let's try to list some of the things which will work on any reference type. Okay, one thing, this is working even in spite of not defining such a method in the rectangle class. Right, we are invoking a method and such a method was never defined. We never defined this toString. Okay, same way, we have another method to return Boolean value which will work on any reference type. Okay, we have got R1, length, width, area. We have got R2 also having some things. Okay, okay. So before we go for the end, right, let's have R1, R2 are two different objects, right? So let's print this. Okay, so we want to print the output of what happens when we do this. Okay, so plus, and let's have, okay. So this is part of the string, but then the other thing will be the actual one, right? Okay, fine. So let's put this in our output before it ends. So one thing here, R1, right? R1 is object of type rectangle. It's referring to object of type rectangle, and then I'm saying, oh, let me use a method called equals, where I'll pass R2 as a parameter. Okay, so we haven't defined such a method, and let's see what happens when we compile. It's compiling. Okay, and let's see the result, the output of that. What do you think is the output? What should be the output? True or false? It's going to give a Boolean value. It is false because they are, yeah. Why false? Yeah. Oh, anyway, the length and width don't match. Okay, let's match the length and width. Then do you think it should be returning true or false? Okay. Okay. What we can do is just before we are using r1 dot equals, let's try to make their length and width same. Okay. How do we do that? R1 dot set dimensions. Okay. 7 by 5. Okay. So if it is set to something else, let it be this. Okay, so they are now both having the same dimensions. That's one thing. Okay, fine. See, for convenience sake, instead of each time doing system out println R1 length is so and so, R1 width is this much. Okay, fine. We can go and define a method, and I would like to do something like this: R1 dot display. Okay, we want to use this, and we find a requirement that we can actually have a, oh sorry, this is R2. When R2 dot set dimensions, both are set to the same dimensions, we will display R1 and we would like to display R2. Okay, I have used a method but I have not defined those methods. And let's go and define this method. Okay, so it becomes convenient for us. So see what is R1 and R2 currently having, right? So in this class, yeah. See, another aspect of the whole class definition is, I always mention, oh, class has these members. Okay, there's no ordering for the members as such. And it's not that always you should have the instance variables being defined first, and then should be the class variable, and then should be the methods, and then should be the constructors. They can be just in any order, will not make much difference. Okay, fine. So we can, okay, so now what we wanted, we want to have a method called display. Okay, so we are putting a method called display. And what are the methods in, okay, so what if we want to do in display is we'll just say system dot out dot println, okay, rectangle plus this dot get length. Okay, or you want to use just simply length, when you may use simply length also. Let's try that, right? Plus length. Okay, plus we can have something like this. plus width and we'll just say class name and the length by width. Okay. Okay, so we want to use display now instead of system out println like this, right? So having created an object, you can just simply call the display method. Okay, we are printing count here and okay. Yeah, this if you want we can comment out or we can keep this still. Okay, but here instead of this I might be better off using r1 dot display. Okay, we are leaving it as it is, but we are also introducing printing it with the fine, just calling the display method there. Get length, get width, all those, yes, that's what we have used. Area we have used. So we let it be. Okay, fine. So the idea here was we have these. Now the dimensions of both of them, R1 and R2, are becoming same. And before we end, we are saying let's print R1 dot equals R2. Okay, fine. So what about the two rectangles? Are they equal? R1 equals R2 is still coming out as false. They are both 7 by 5. We can see that. Okay, rectangle 7 by 5. Yeah. So fine. So what's the reason why R1 equals R2 is still false where the dimensions are matching? Okay, fine. So let's look at that aspect again. Okay, another thing earlier was we have used a two-string method. We have never defined it. We have used the equals method and we never defined it, and they work. And these will work for any reference type. Two-string is going to work on any reference type. Okay, equals is also going to work on any reference type. How come? Why do they work? Okay, the reason here is, okay, fine. Okay, the reason for these things to work is this. Let's check this out. Okay, there is one fine. I think I have mentioned about this earlier once. Okay, there is a class called object. Fine. So Java has a class called object, which is the super type for all the reference types. Recollect when we were looking at that, we had, I think when we were looking at the operators and statements, yeah, there was this ternary operator. Recollect the ternary operator when we discussed the ternary operator, right? At that time, I mentioned about object being a super type for all the reference types. What is the common supertype between car and date? What is common to them? They are both object. And between car and truck, oh, they were both vehicle. Right? But when we say car and date, we don't see a relation between them, right? But then what is considered in Java is something like this. Everything is object. Except for the primitive types, everything else is an object. Okay, so we can think like this, that object is one super type and everything else is going to be defined under this only. So when we define the class rectangle, okay, it was deriving from the class called object. We have defined the class rectangle, but this rectangle is actually inheriting from whatever is defined the object class. Okay. Methods from object class get inherited by every reference type. It's available for every reference type. Okay, so now you get why we don't get errors when we use a toString method. What it means? It's a method which was inherited from the object class. So it's an object class where methods like toString, method like equals, yes, this is what we have tried so far. There are some other methods as well which exist in the object class. So that is going, as soon as you define a class, those methods are available to you. Okay, those methods are going to be available to you. Okay, fine. So I'll just put a list of the methods which are available in the object class. Okay. Fine. We may not go over all of those methods currently, but for some of the methods, yes, we'll see the purpose, what is there. Okay. Yeah, what's the purpose of these two methods which we have used? What's the purpose of toString method? Okay, in the object class, first thing, yes, in the object class, if I look at the object class, so within the object class, the methods which are available, one of the methods, yes, we will be using some few other keywords which we have not yet explained. For example, we have the keyword public being used. Okay, so we have in the object class, we have some public methods, and among those is a method which returns string. Name of the method is toString. And without any parameters. Okay, and so this is one of the methods which we, and this is what we have actually, this is what is used for conversion to a string. So when we have to convert to a string, yes, it's a toString method which is used from the object class. So object class has a definition how toString must be done. Okay, same way, object class also has another public method which returns a Boolean value. Name of the method is equals, having a parameter of type. So when it says object, when the parameter says to be object, it means any reference type can be used here. Okay, it's defined for accepting any reference type. All reference types are objects. Okay, right. So these two methods, yes, there are actually total of 11 methods in the object class. Okay, fine. Fine. Yeah, so this is why it is working, because we have the class called object. Okay. Some other methods, if you want, I can try to list them, but we'll not discuss them at this moment. Fine. For these two, we know the purpose. First one, conversion to a string. Second one, checking equality. Okay, whether they are equal or not. Okay. We also have another method. So every object, fine, has a int value associated with it. It's called the hash code value. So all objects have a hash code value. So there is a hash code associated with every object. Okay, we have a hash code value for objects. Right? So you can use r1.hashcode. It will give you the integer value. Okay, right then. Okay. Next, another method which we have, it's a public. Okay, but one more keyword has been used with this method name, final. The return type for this method is called class. See, like we have a class called object, we also have another class called class. So see, this is name of a class. Object is also name of a class. Class is also name of a class in Java. So Java also has a class called class. Okay, and name of the method here is the get class. So given any object, you can always ask what is the class of that object. What is the class of that object? This here, right? This thing, which is name of a class. That means for every class, for every object, there is a class definition available. Okay. Fine. See, yesterday also I was talking about static variables. Where are the static variables? When do they come into existence? When the class is loaded. Okay, what exactly is meant by loading a class? Okay, when say, oh, we say the class is getting loaded first and then object of that class would be created. Okay, so let's try to understand that. See, we have class files for the types which we have defined. And for example, rectangle is a class, so there is a class file for rectangle. String is also a class, so there is a class file for the string class. There is a class file for the system class. Okay, so before the string can be used, yes, we are using string when we are saying string arrays, right? Okay, so before anything can be used, any object of any data type can be used, any reference data type can be used, their class will need to be loaded into memory. Okay, and that's a place where static variables exist for that, from that class definition. Okay, so we said yes, there is a place where the class definition of the rectangle class has been loaded. Okay, static variable is part of this, right? This is, now this what is there is actually one object. When a class is loaded, an object is there which holds the information about the class, and this is the object of the type class. Okay, so for every class definition, for every reference type which has been loaded, there is one object of the type class. But one thing here, these objects are not created by calling their constructor. We can't say new class and say, oh, let me have a class object. The object of the class are only created by loading a class definition, not with the help of a constructor. Okay, we don't have a constructor available to create object of the type class. So class is name of a class. We don't use constructor to create object of this class. Object of this type of the class are created when the class is loaded. So for all the classes which are being loaded, an object of this is created. When we say new rectangle, see, before we said new rectangle, okay, the object of the class which represents the type rectangle has been loaded. Okay, and that's where it is keeping that count thing, right? Count is a static variable in that. Okay, so it's keeping the value of count in that place. So it's being kept in an object which is of type class. Okay, fine. When we say new rectangle, yes, a rectangle object has been created by looking at this definition. This is a class definition, and from that I create rectangle knowing that it has got two instance variables, length and width. Okay, so a rectangle object, we said R1 equals new rectangle. Yeah, this is R1 referring to this object. But this object was created by this definition. This object knows that I have been created from this class definition. Okay, fine. If I use R1 dot get class, what will I get? There's also another rectangle object, you remember, which is created from. So we have R2, and you can just imagine R2 also being created. It also has its length and width, right? But this also remembers the same object. They are created from the same class definition. On any one of them, if I say get class, what will I get? I'll get the reference to the class object. So I can always say class, see, this is a valid code which I'm writing, class CLS1, let's say, it's a variable name, equals this. Okay, so there is a class object, fine. For from any object, I can say, give me the class object for it. Fine. So what can be done if you have a if you have any on any reference type, we can have string conversion. We can have equals, comparison for equality. They have an integer value called hash code. All objects have an integer value called hash code. Okay. Given any object, I can know their class object. I can get their class object. Fine. Currently, we are not going into what all is available in the class. With this class, what we can do. Yes, later we may like to have a look at that also. But at this moment, just understand, yes, there is some place where the class definition has been loaded, and that is in a form of an object. Okay, and that object will also be available to us. Okay, fine. So we can also use the get class method for that. Fine. We have seen 4 methods, right, so far from the object class. The idea here is, yes, that every class is deriving from the object class. So these methods become available. Okay, fine. Fine. Any questions? Yeah. Okay. Fine. Then let's proceed then. Okay. Fine. Let's continue with what goes in a class definition. Okay. Yeah. What all goes in a class definition? Now, if we look at our class definition, the way we have defined, okay, there was something which happened. Okay, let's look at that code first. Yeah. Rectangle class, what is the code? Okay, fine. So we go back to the rectangle class, the code for the rectangle class here, right? So in the rectangle class, if you look at the constructor here, we have said count plus plus, right? Okay, we want count plus plus to be done each time the constructor of a rectangle is called. As soon as a new object is created, I'm interested in increasing the value of count. Fine. Now, we don't put it in both the constructor because here, if I put it in this constructor, it cannot be before this, and by using this, it has already done the earlier code, right? But someday, maybe there is some modification which someone is making on this class, and he has commented this out, okay, and he is doing something else here, okay. Some other way is maybe calling the set dimensions here. He says, I don't need to call that constructor. Let me try the set dimensions, and I will use side comma side. Okay, so that should achieve what I was achieving in that. Okay, now when he does this, he forgets to put the count plus plus. Okay, so now what will happen? Oh, if someone uses single parameter constructor, the count is not incremented, and if someone uses two parameter constructor, the count is incremented. Fine. And tomorrow someone adds another constructor to this and he forgets to put count plus plus. Count plus plus, I'm always thinking, oh, it should be done each time a constructor is called, independent of or irrespective of which constructor he uses. You may use constructor with one parameter or constructor with two parameter, anything you do, but if you are creating a new object, fine, let's see this. So if you are creating a new object, so okay, so we have this kind of a code, yes, which we had, but this code, this one line here, I don't want it to be missed out. Any constructor you use, this must be done first. So that can be specified in what we call as a initializer block. So in a class, we can have something known as an initializer block. Just put a simple block inside your class definition. See, as a member of a class, what are we having? Variables. Static or non-static. So it is an instance variable or a class variable. We have methods. Static or non-static. So instance method or class method. We have constructors. Okay. Now what we are putting is it can have an initializer block. So you can just open a block as a member of the class and put your count plus plus over here. Yes, you can do this here. Okay, so count plus plus, this is a statement which I have put inside a initializer block. This block is executed so this will be executed before the constructor code is executed. Okay, so class can have a initializer block. Okay, class can have a initializer block. Okay, fine. We also understand one more thing. So, and we also understand one more thing, that What is the purpose of a constructor? Have you seen understood what's the purpose of the constructor? Because the object is being created, the instance variables are allocated. We want them to be getting initialized with some value. Okay, right? We don't want them to be just 0, 0, 0, the default values there. Okay, but anyway, whenever a new object is created, it is the constructor which is executed. The purpose here has been we will be setting up the initial values for the instance variables. We use it to set up the initial value of the instance variables because the life of instance variable starts when the object has been created. When they are getting allocated at this moment. So as soon as something is allocated, we want to execute what we call as a constructor. Okay, as soon as the object is allocated. What about the count? Count is a static variable. Okay, count is a static variable and we may like to execute something. We will like to have their initialization done for a static variable. Okay, so we have another kind of a member which can go in a class definition, just like a block with the keyword static. So if you have a block preceded by the keyword static, this is known as a, we call this as a class initializer block. Okay, so this is a class initializer block. So this is executed. So as soon as a class is loaded, we understand the class object for this will be created whenever a class is loaded. And that's the time when the static variable is allocated space. Fine, static variable come into existence when the class has been loaded. So first thing which is done is loading of class. Before a class can be used, it will get loaded. So at that moment, static variables are getting allocated. Okay, they get their space and we would like their initialization to take place. By default, they would anyway be 0. Fine. Integer values, numeric values will be initialized to 0, but still just to remind that the purpose here is to initialize, give the initial value to our class variables. Static variables, their initialization can be done in the static block. Right? We call this as a class initializer block or a static block. So what are the members of a class? Okay. Let me put the notes here. Yeah, what are the members of a class? Instance variables, right? Instance means the object, okay? Okay, fine. What's the other kind of member? So from variables point of view, yes, we have two kinds of variables, instance variables and class variables. Okay. Okay. fine, not dependent on object. Okay, fine. Okay, in both cases, okay, instance variables by default so numeric type of instance variables are zero, boolean, false, and reference type to null. So if there is any reference data type, you have declared string, right? Maybe the string name, maybe you want to give names to a rectangle. Okay, then by default it would get a null. Okay, it's a null reference. Fine. So same thing is true for class variables. Okay. So their initial default value will be this. Okay, here normally when they are normally getting initialized to the constructor. Okay. Fine. You may also set them up in the initializer block. Or also called as a class okay, this is also known as a class initializer block, where it can be initialized. Okay. Yeah, third kind of member, methods, or you can call them as instance methods. Yeah, what are methods? When they define the interaction with the object of the class. Okay. Okay. Fourth thing. Fine. Okay. Yeah. Independent of object. Okay. So they don't depend on object. Right? Without object also they can be used. Used with class name. Okay, example is rectangle.getCount. right? What's the fifth thing? Okay, so we have something called initializer block. Okay, fine, we understand how it is written. Actually, we missed on the constructor part. After methods, I think we can write the constructor here. Fourth thing can be constructor. Okay, so what are the yeah, so constructor, right? So what is a constructor? Okay, executed whenever new object of a class is allocated. Fine. So constructors are executed when we use new. Okay. One more thing. What's the difference between the two kinds of methods? A static method. Okay, I think I should have kept it. Sorry, I'm just shifting it again. Static methods. Yeah. Okay. So fine. Used methods, right? They're like methods. So when the object is created, that time we are calling this method. Okay. Executed whenever the, so what about the initializer block? Executed whenever the, okay, it's similar to this, right? Okay. But, okay. Okay, so this would be getting executed first and then the constructor. And the seventh thing which we have seen, what can go in a class definition? See, we are just looking at members of a class, possible kind of members of a class with that purpose. So yes, what can be executed? What are the other members? There's one more member. We have the class initializer block, or we call it as a static block. Okay, so we also call it as a static block. Okay. Yeah. So class is loaded only once. Remember this, a class is loaded only once. Okay, not each time you create a new object, no, it won't be loaded. First the class is loaded, then objects of the class can be created. Okay, before a class can be used, creating a new object, that means you are using the class. So before a class can be used, it will have to be loaded first. Okay. So it is used for initializing the static, or we call it as a class variable. Okay, fine. So that's what is the purpose of the this. Okay, now other thing which we have just marked today is, okay, we have objects class, okay, we have a class called object. And okay, instead of saying from where, let me say and for any reference type which you are defining, object is the super type. Okay, it includes arrays also. Okay, and this includes array. Array is a reference type, we know this. Okay, fine. So we have some methods which are in the object class. Okay, okay, it has total of 11 methods. I'll list all the methods, but we'll not go into detail of each of those methods at this moment. Okay, so object class has 7 methods, sorry, 11 methods. Okay. Okay, so we'll try to see the purpose of whatever we can at this moment. Okay, one thing is, any class you define, understand this is what will be available, though you are not putting those methods in them. Yeah, so what are the methods we have seen? First method, string conversion. So public string to string does not require parameter, and that's the first method. Okay, purpose is string conversion, and the purpose is string conversion. Okay, next one, it can take any other reference type as a parameter. Object means all reference types are, oh sorry, fine. Fine. Okay. Yeah, by default it works. Okay. That double equal to, whether it is same or not. But we'll see how we can have our own equals method for our class. So when we define our class, yes, we can do that. And this is by default. Okay, by default, what is the string conversion? Class name. Okay, it is giving. Okay, and then at the rate, and then this is a hex value, right? It is the hash code value, which is the what is the number, but in hexadecimal form. Okay, so that's the default string conversion. Okay, fine. Other method. Yeah, what is the other method we have seen? I've listed it. Yeah. Yeah. So int hash code. Fine, we have this method called hash code. Okay. Okay, then another public and final also. Yes, we have not seen the meaning of final, but that's how it is. So I'm just putting it here. Okay, get class. No parameters needed. Okay. And so there is a separate class object for each class. Okay. There is a separate class object for each class which is loaded. So one class object for per class definition. Okay. Okay. So what does this method do? This method returns the class object. Okay. For the given object. See, object is always of some particular type. So you may create a rectangle object. So there is a class object for the rectangle class. Okay. So that will be returned from the, if it's a rectangle object, then you're saying, okay, same way you could be using a string object and say string s1 equal to, you have said hello world, right? And then you could be getting the object of the string class definition. Fine, clear? So, okay, I've listed these 4 methods so far. I'll list the other methods just to have a completed list. Okay, so we have the protected method returns. Okay, there are a couple of methods which are protected. There's a method void. finalize. Okay, fine. Now this method from last few versions of Java, this method has been this method is deprecated. Deprecated means they are saying don't use this method. They are discouraging the use of this method. Okay, fine. So the purpose of this method was different. Okay, it's more like if someone is making a comparison, it's more like closer to a destructor, though not exactly a destructor. Like we have constructor, there's something called destructor. C++ has the concept of destructor. Okay, but this used to be like the garbage collector. When we understand garbage collector thing, because when an object becomes unusable, fine, that becomes a garbage, and then that needs to be deallocated. That space needs to be deallocated. So this method was used by the garbage collector, fine, before deallocating an object. Rather than used, I should say, was or I'll rewrite it. So any object it is deallocating, the garbage collector is first calling the method called finalize and then deallocates. Another protected method, okay, I'm not giving much explanation for these protected methods. This protected method would return an object. The name of the method is clone. Okay. Okay. Let me put one more thing which is here. Okay. So that's how the method signature is. It has a method can have a throws clause, and we are not looking at currently what is this throws clause about, but that's how this method has been defined. Okay. So object class is defining the method like this. Okay. 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 Normally throws an exception. So the object must be a clonable type. Okay. Fine. In bracket, let me put it. Okay. Fine. We'll go into those details later. But yes, we have a method called, oh, it's not close, it's, sorry, clone. Sorry about that. Yeah. Method name is clone. Okay. Fine. Other than this, yes, still we have 5 more methods. These are 6 methods in all up till now. And there are 5 methods which are used in the concept of multi-threading. Java is a multi-threaded platform. So we have these methods, some methods which are more useful with the multi-threading here. So we have these public methods now, public and final. All of these methods will be public and final. Okay. Name of the method is wait. Return type is void. Method name is wait. Okay. Throws. And that's how it is. Okay. Fine, we'll not mention what it is about. Yes, we will have a look at it when we look at multi-threading. The same method, what overloading is done where it takes long milliseconds. Okay, it's a timeout value basically. And another, you might have a more precise timeout value. This is specifying in milliseconds, but instead of milliseconds, you might say so many milliseconds and so many number of nanoseconds. Okay, so you can give your precision level can be higher while giving a timeout. This is timeout. Parameter here is timeout. How much timeout? The wait method has a timeout. Can have a timeout. Okay. We also have public, final, void, notify, and public, final, void, notify all. Okay, fine. So these are, I'm just listing these last methods related to multi-threading and not giving any explanation at all at this moment. Okay, but this just to complete the list of 11 methods for object class. Okay, see, if we have these methods of object class, okay, what should also be possible? So you have an int array A equals, and you got maybe you created like this. Okay, something like this was done. Okay, so you got an object, and you could say system.out.println a.toString. The idea of what I'm showing here is all these methods of object are available for every type, every reference type, right? So even with array, oh, it's an array type, but I can use a toString. Even with array type, I can use equals. I can use hash code. And I want to print the hash code value. Okay, fine. I'll give you a few other useful methods. Fine. Not only in the object class, but I'll just give you about another class here. Okay. For example, I can say a.hashcode. You can print the hash code value. I want to print the hash code value in hexadecimal. It's of type int, right? So I can say integer dot. Now integer is name of a class. And if I am using a method called dot to hex string, right? You can understand that this is a static method. You can write like this. Right. So there is a method like, so if you want to have something printed in hexadecimal, some numeric value printed as a hexadecimal, this is the way you can do it. You should understand that this is, when I'm saying this is name of a class, it means that this method here, toHexString, is a static method in that class. I have not created object of the integer class and then using it on this. It's directly using class name dot method name. So when it's a class name dot method name, it implies that this is a static method. Okay, fine. Now same way, what about this? When I'm saying system dot out, system I said is the name of a class. So what is out? It's a static variable in that class. Fine. So out is a static variable in the class called system. Fine. Now we understand that yes, if a class name is used, that means we are talking about static members. Static variable, static method, they will be preceded by the class name. Fine, clear? Okay, fine. So yeah, so it's always like this. We have the we have got class object as the topmost class. Fine, everything is deriving from there. Everything is inherited from there. Okay, fine. So yes, we have created the class. How do we inherit from a class, right? Okay, so how do we do this, right? So for this, we have a keyword called, okay, extends. Fine, we have a keyword called extends, right? So actually what happens here, when we define the class rectangle like this, right? We said class rectangle. Okay, maybe we didn't have anything inside the class rectangle. Though you write like this, okay, okay, the above class is, okay, equivalent of, so though you write like this, it is actually equivalent of the following. Okay, it's like this. So it's just like saying rectangle. Okay. You don't mention object extends object, yet it will take it as extends object. So you are not giving extends for a class definition. It would mean that it extends from object. Okay, I have written only object, but we do understand that it's not just object, it is, okay, there is a prefix of java.lang. Clear? Okay, so anytime you are defining a class and not mentioning an extends, okay, and clear? So now the next step here, right? So our next steps will be about defining a subclass, okay, for the rectangle class. So we already have a class called rectangle, and we might go for a subclass of the rectangle class. Next step, okay. So rectangle has been defined in general, but now we might be going for subclass called rectangle. Okay, So next, this is what is the next step. Okay, fine. Rectangles have length and width, right? And normally we say, oh, when we inherit the variables, and in a subclass, what it's going to inherit everything what is there in the superclass, including the instance variables. Okay, so if you think about a cuboid class, right, we may think that yes, this cuboid class has got a cuboid has length, width as well as the height. Cuboid has length, width and the height. So cuboid can be defined as a subclass of rectangle by adding one more instance variable. Okay, fine. So I'm just trying to imply an example could be something like this. Class cuboid extends from rectangle class, okay, and it could then be saying that yes, I have a additional instance variable called, how many instance variables for the object of cuboid class? I have only declared one, but how many are there? Because of extends rectangle, there are two already inherited. Okay, it will be inheriting two of those. Right? So our next step is about understanding the inheritance aspect. Fine, clear? Okay. Fine. So any questions now so far? Fine. We are covering. We have covered some slightly uh, maybe at initial level it may look slightly complex, but yes, but I think you should have understood the concept of, one was the class called class, and it's related to the class loading. Everything has to be loaded first. Any class has to be loaded before it can be used. Fine, but and that's to be understood because static things, right? Where are they? And they are not part of objects. Where are they then? And there's only one copy for them. Okay, independent of object creation. Right? Say I'm putting all this so that there are many texts where slight wrong information is being managed. Okay. Fine. For example, many places they'll say a static variable is a variable which is common to all objects. Okay, it's a variable which is common to all objects. See, even without object, this variable exists. Okay, so whether object or not, it's independent of objects rather. Okay. Okay, so next topic will be on inheritance. And fine. Okay, so you want to discuss anything from today's thing or anything so far? If there is any topic which you have not understood, because we have some time. Okay. Yeah.
So I have a question.
Yeah, sure.
In general, if you go for an interview,
Yeah.
did they ask the definition or just a concept thing?
Concept. Mostly it's a concept which they will like to have.
Yeah, so because like I know they ask the definition for concept, but you know, like when you describe you all these things, so they will not ask for the definition.
Okay. They don't ask definition, huh? Normally. Yeah.
Okay, thank you.
But the concept must be, it should be clear. The idea is that you're clear about what is where, right?
Yeah, yeah. So like I have some idea about like literally they ask about some object will be in the picture and everything, but
Yeah.
I'm not sure with the definition.
Yeah, yeah.
That's why I asked.
Yeah. See, when we look at that exception thing, at that time we'll have much bigger picture about what's there in the JVM, because we'll have the runtime stack, concept of the runtime stack, how the execution is happening. Okay, and that's also related to multi-threading. Okay, so exceptions and multi-threading, they will be related to each other. Okay, and they are quite related things, and that's the time when you understand, oh, there's a heap, objects lie in a heap, runtime stack is where the execution happens. Okay, so that's also another important thing you should know. Okay. Okay, so any other questions? Yeah. Fine. So, fine. Tomorrow, I think we'll look at the inheritance concept, and that we can continue tomorrow. And it will, what you can do is this rectangle class experiment. You make some changes, or you define your own separate class and try out all these concepts. Okay, whatever we have seen today, fine. That you should try on your own. Fine. Anyway, I'll push the Git repository. Fine. You're able to get from the Git now, right?
Yes.
Okay. So let me push to and just push it to the Git repository now itself. Okay. Okay, so it has been pushed, and so this will be available, right? Both the files updated. So my advice is that yes, make changes in rectangle.java here. Sorry, I didn't save this. Oh, sorry. So fine, experiment with this. Like, fine, we know that static block should be executed first. Put system out println over here and see that that is what is executed first. Fine. Put system out println in this initializer block. Fine. Just try to track, fine, how the execution happens. Okay. Fine. And experiment. So the idea is you experiment, and then you can have questions, right? In so next day you can always ask the questions. And when we begin, you can always ask the questions from the previous sessions. Okay. So it's important that you try out the things, and you should be thinking about, okay, what's happening, right? And if you have new ideas, it's good, try it, and then we can discuss it next day. Okay.